Hello everyone, my name is Lakshmi Nivas. I'm from Computer Science and Engineering branch of Section B. So today we're talking about the subject chemistry. So today's our tech talk topic is cleaning up coal's second act. So we'll discuss more about cleaning up coal's second act. Introduction. Steam coal or thermal coal first are milled into a fine powder, which increases the surface area and allows the coal to burn easily and quickly. In these pulverized coal combustion (PPC) systems, the powdered coal is blown into the combustion chamber of a boiler where it is burned at high temperatures. The hot gases and heat energy produced converts into water in tubes lining the boiler into steam. The high pressure steam is passed into a turbine containing thousands of propeller-like blades. The steam pushes these blades, causing the turbine shaft to rotate at high speed. Electricity is generated when these are rapidly rotated in a strong magnetic field. After passing through this turbine, the steam is condensed and returned to the boiler to be heated at once. The electricity generated is transformed into the higher voltages up to 40,000 volts used for economic efficient transmission via power line grids. When reaches the nearest point of the consumption, such as our homes, the electricity is transferred or transformed down to safer 100 to 250 voltage systems. So this is the, the diagram of how a steam coal or a thermal coal plant works. From here, the coal supplies going into the factory so that the coal is burned and the steam will pass through the steam line, and the steam line goes up to the turbine, and the turbine runs on the steam, on the flow of and the pressure of steam, and then the generator generates the electricity and transforms into the transmission lines, which controls the amount of electricity which has to be distributed throughout the city or throughout the town. So let's go to the next slide. Clean coal. What is clean coal? Basically, clean coal means capturing carbon emissions from burning coal and storing them under earth. Here, the carbon capture is very useful, but it is very expensive to build or ship them to existing industries, which can lead industrialists to bankruptcy. This is the reason most of the industries were shut down all over the world. There are many dangers on burning coal too. Here, the term clean coal has been applied to many technologies ranging from wet scrubbers, coal washing, digitalization, etc. What are wet scrubbers? Well, wet scrubbers are those which filter or remove sulfur dioxide precipitate, the gas which is generated from the coal burnt gas. So this is the we can visualize this diagram that this is how clean coal process happens. So some disadvantages of wet scrubbers include corrosion, the need of entrainment, separation or mist removal to obtain high efficiencies, and the need for treatment or reuse of spent liquid. This is the scrubber which is used for clean coal process. This is how the coal or gas inlet enters into the scrubber, and then the precipitate is formed here, flooded elbow. Then all the drain will be passed out from a small hole which is beneath at the bottom point here, as we can see. So the gas will circulate through this whole cylindrical chamber and it goes outside, which uh, leads to pollution in atmosphere, open atmosphere. So this is how clean coal process is happening in many of the industries. This is what a scrubber looks like. So let's go to the next slide. Coal washing. Coal washing is a type of process takes place in clean coal processes where the coal extracted from the underground is washed properly to remove soil dust and rock particles for the proper usage of it. So this is how a raw coal is extracted from the mines. And raw coal means it consists of many dust particles, mud, and rock particles, which has to be separated for further uses. This is how the raw coal enters into this pipeline, and then it goes to the chamber, cleaning chamber, coal washing chamber, and this is the fluid which uh, cleans the coal, and the whole chamber turns in a cylindrical way, in a circular way, so that the dust particles will be separated from here. The impurities get separated here, as you can see here, and the washed coal will be separated in this way, which comes outside from the chamber. This is how coal washing is done. And what is digitization? Digitalization in mining refers to the use of computerized or digital devices or systems and digitized data that are to reduce costs, improve business productivity, and transform mining practices, which results demonstrated that currently 107 different digital technologies are pursued in the mining sector. So this is how uh, the digitalization of coal. So plant life cycle, and from there it goes to enterprise operation intelligence, and then automations, mineral automations standard based on PCS 7, which is called as digitalization in coal sector. So this is a these are some factors which involve in coal mining. Let's go to the next slide. Carbon capture and storage. CCS, carbon capture and storage technology, has been around since 1980s, while the other technologies mentioned above cut down on sulfur dioxide and coal ash. CCS is meant to handle the big environmental nightmare, the heat trapping gas largely responsible for global warming and carbon dioxide, which is global warming is rather than carbon dioxide, CO2, which is the chemical in carbon dioxide. Here you can see that this is how the emissions are released into the air, which gets here. You can also see that the coal ash from volcanic eruptions, and these are some industries on the water body which uh, releases emissions, and from here the waste toxic liquids are released into the sea, which affects totally the environment. Environment is completely spoiling, and industries are really spoiling the whole atmosphere here, as you can see in this picture. You can visualize it. So coal plants today typically use what is called pulverized coal. That means the coal is ground up, burned, and steam from the burning drives turbines. These also newer integrated gasification combined cycles, which is IGCC. This is a type of technology which sends the gas through a combustion turbine to generate electricity, and then routes excess heat from from that process to generate even more electricity through a traditional steam turbine. This is how CCS works. I mean, CCS is, then we go to the next slide. Pre-combustion in CCS. In either process, there are multiple points at which CCS technology could intervene. One such point is called pre-combustion. At this stage, an air separation unit produces a stream of almost pure oxygen, which flows into a coal gasifier. Gasifiers are essentially tanks that produce synthetic gas mixtures known as syngas. So this is how syngas is. This is the tabular form of syngas, which leads to various factors and various points. So what is advantages in CCS? Well, the oxygen in this coal gas pair reacts with fuel to create a syngas made up of hydrogen, carbon monoxide, water, and CO2. This form of syngas is nothing new. Invented in the 1790s by William Murdoch. In the 19th century, it was used to power gas lights in many towns and gained the nickname of town gas, which is used for generating electricity. This content is imported from embed name. You may be able to find the same content in other format, or you may be able to find more information at their website, as this website is so useful. What is a syngas? So, a syngas is more relatively known as synthetic gas, which is a mixture of hydrogen, carbon monoxide, and very often some carbon dioxide. Syngas is usually a product of coal gasification, and the main application is electricity generation. Syngas is combustible and can be used as fuel of internal combustion engines. Historically, it has been used as a replacement for gasoline when gasoline supply has been limited. For example, wood, gas was used to power cars in Europe during World War II. In Germany alone, 500,000 cars were built or rebuilt to run on wood gas. However, it has less than half the energy density of natural gas. Earlier, when there was a shortage of gasoline, which was used for cooking, syngas was used as an alternative gas for cooking, which even produces heat and fire on igniting it, and it is even less dense than other gases, which can become an eco-friendly alternate for the future needs. This is how syngas is used. These are the advantages, and this is how syngas is used in our daily life since 17th century. Production of syngas. The chemical composition of syngas varies based on the raw materials and the process. Syngas produced by the coal gasification generally is a mixture of 30 to 60% carbon monoxide, 25 to 30% hydrogen, and 50 to 15% carbon dioxide, and 0 to 5% methane. It also contains lesser amount of other gases. The main reaction that produces syngas is steam reforming, is an endothermic reaction with 206 kilojoule per mole methane needed for conversion. The first reaction between incandescent coke and steam is strongly endothermic, producing carbon monoxide, which is CO, and hydrogen H2. Water gas is older terminology, which is the older terminology of H2 hydrogen water gas. When the coke bed has cooled to a temperature at which the endothermic reaction can no longer proceed, the steam is then replaced by a blast of air. The second and third reactions then take place, producing an endothermic reaction, forming initially carbon dioxide and raising the temperature of the coke bed, followed by the second endothermic reaction, in which the latter is converted to carbon monoxide, CO. The overall reaction is exothermic, forming producer gas, older terminology. Steam can be re-injected when air, etc., to give an endless series of cycles until the coke is finally consumed. This is how a syngas is produced, the production of syngas. These are some chemical reactions of syngas. When used as an intermediate in large scale, industrial synthetic of hydrogen, practically used in production of ammonia. It is also produced from natural gas via the steam reforming reaction as follows. CH4 plus H2O gives CO plus 3H2. In order to produce more hydrogen from this mixture, more steam is added and the water gas shift reaction is carried out. So the reaction is carbon monoxide plus water, which is H2O, gives rise to CO2 plus H2. The hydrogen must be separated from CO2 to be able to use it. This is primarily done by pressure swing adsorption, which is PSA, amine scrubbing, and membrane reactors. This is how the production of syngas is done. So this is biomass, and biomass is passed through and which is burnt, and the steam is produced by a gasifier, and gasifier which outlets the steam like this, and the car outlet will come from the bottom of this pipe, and from here how a syngas is produced, clean syngas, which is H2, which is a composition of H2, CO, CO2, and CH2. This is how a syngas is collected in industries. So let's go to the other slide. Electricity from syngas. Depending on the technology used for producing synthetic gas, electricity may be one major input. Use of electricity to extract carbon dioxide from water and then water gas shift to synthetic gas has been tried by the US Naval Research Lab. This process becomes cost effective if the price of electricity is below 20 million $20 per MWH. Electricity generated from renewable sources is also used to process carbon dioxide and water and synthetic gas through high temperature electrolysis. This is an attempt to maintain carbon neutrality in the generation process. Audi, in partnership with company named Sunfire, opened a pilot plant in November 2014 to generate e-diesel using this process. This is the process of e-diesel. Air to compressor in the beginning, gasifier, as we have seen in the previous slide, the gasifier, cyclone, turbine, which turbine produces electricity, and also due to this gasifier, it produces syngas. So both benefits are acquired here, electricity as well as syngas. So let's go to the next slide. Uses of syngas: gas lighting, energy capacity, sponge iron, and diesel. Coal gasifications processes to create syngas were used for many years to manufacture eliminating gas, which is coal gas, for gas lighting, cooking, and to some extent heating before electric lighting and the neutral gas infrastructure became widely available. Energy capacity. Syngas that is not methanized typically has a lower heating value of 120 BTU per SCL. Untreated syngas can be run in hybrid turbines that allow for greater efficiency because of their lower operating temperatures and extended part-time lifetime. Sponge iron. Syngas is used to directly reduce iron ore to sponge iron. Diesel. Syngas can be used in the Fischer-Tropsch process to produce diesel or convert into, for example, methane, methanol, and dimethyl ether in catalytic process. If the syngas is post-treated by cryogenic processing, it should be taken into account that its technology has great. If the syngas is post-treated by cryogenic processing, it should be taken into account that its technology has great difficulty in recovering pure carbon monoxide with relatively large volumes of nitrogen and present due to carbon monoxide and nitrogen having very similar boiling points, which are 191.5 Celsius and minus 195.79 degree Celsius respectively. So these are uses of syngas, which are gas lighting, energy capacity, sponge iron, and conversion of diesel. So there are some other uses of syngas. Methanol, where syngas is used to produce methanol, as in the following reaction: CO2 plus 3H2 gives rise to CH3OH plus H2, and even hydrogen. Syngas is used to produce hydrogen for the Haber process. Syngas from waste. A variety of waste gasification system has been developed in the years 1991 to 2000. As an example, Logan City Council, Australia, will use a waste gasification process to dramatically shrink the volume of waste needing to be trucked off-site and produce syngas to power the facility. Once wastewater is treated to kill off harmful pathogens and bacteria, the remaining biosolids will be heated to high temperatures to produce a syngas mixture made up of mostly hydrogen, carbon monoxide, methane, and carbon dioxide. The syngas produced in waste to energy gasification facilities can be used, for example, to generate electricity. As we have discussed in the earlier slides, it can be used to generate electricity and to generate methanol, hydrogens, diesel, and other biofuels. What about cleaning coal in India? There was the same situation happened in India during 2003. As part of its climate change commitments, the government had made coal washing mandatory for supply of 2,000 units more than 500 kilometers from the coal mine. This was in keeping with India's stand to not reduce coal consumption but rather focus on emission control. What is the demand of coal in India? India's growth appetite for India coal is set to add 130 million tons to coal demand between 2021 to 2024, which is still going on. The expansion of India's economy is expected during 2022 to 2024, with annual average gross domestic product, means goods product, growth of 7.4%, fueled at least partially by coal. Why coal is used in India? Coal is used to meet over 70% of India's electricity needs. And the second point is most of this coal comes from domestic mines. And the third point is in 2020 to 21, India produced 716 million tons of coal compared with 431 million tons a decade ago, which happened during last year recently. So let's go to the next slide. This is how coal is important in India, how coal is used in India. So let's go to the next slide. Does coal have future in India? So coming to this, according to the analysis, despite the international pressure to move away from coal in October 2021, the Indian government a target to produce 1 billion tons of coal by 2024 to secure the country's energy requirements. For India, coal is here to stay for the near future. This is the gas. This is the graph where it indicates that how much coal is essential in India. So steel is from 0 to 2, it is nearly 1 we can say, and cement is absolutely 1, and renewable sources are up to 10. Renewable sources are many, like we'll discuss about later, and IGCC and plant efficiency, which is at 4, and fuel switching. Fuel switching means from converting from diesel petrol to battery, which is called fuel switching, and coal washing. Here we can see that coal washing has crossed and defeated all the factors which are involving in this graph, because this is how coal washing is, and the usage of coal in India, which is most important factor in India's thermal plants and also daily life usages. So electricity production in India, how is it possible in India? Electricity production in India is mostly achieved through coal thermal power plants, which you can see in figure 1. This itself is a figure 1. Although there have been efforts to diversify the options, particularly in the case of renewable energies, coal remains the dominant source of electricity in country. This is how coal is used in the future, and how the need in India, how the need of coal is in India. So let's go to the next slide. Is India self-sufficient in electricity production? India attained 63% overall energy self-sufficiency in 2017. The primary energy consumption in India grew up by 2.3% in 2019 and is the third biggest after China and USA with 5.8 global share. India is surplus in electricity generation and also marginal exporter of electricity in 2017. India is third largest producer of electricity in the world. The per capita electricity consumption is low compared to most other countries. Despite India having a low electricity tariff, India has a surplus power generation capacity but lacks adequate transmission and distribution infrastructure. So this is how the graph indicates the growth of electricity generation, renewable and conventional. And this is financial years of the coal usage in India. So conventional and the blue graph indicate the blue bar indicates conventional generations, and the orange bars indicate the renewable generation. The renewable generations are more in which are sustainable and sufficient here. The conventional generations are comparatively at the same level as we can visualize in this graph. So let's go to the next slide. Cleaning coal in China. China's latest financing initiative for clean coal technology will help the country meet its energy needs while at the same time reduce the carbon intensity of its heavy industries and meet its goal of capping coal consumption by 2025. Analysts said, but some argued that it could instead prolong the use of fossil fuel and keep the industry alive in the mainland. What is the actual impact of coal on climate? This is very important for us. Coal is the single biggest contributor of anthropogenic climate change, which is a drastic amount of heat and emissions produced into the open atmospheric condition, in open atmospheric place. The burning of coal is responsible for 46% of carbon dioxide emissions worldwide and accounts for 72% of total greenhouse gas (GHG) emissions from the electricity sector. So these are two factors which affect the atmospheric uh, emissions, means the greenhouse emissions, which are produced by electricity conversion due to coal and also the burning of coal, which is 46% alone and 72% on greenhouse gas emissions from the electricity sector. So this is how the greenhouse effects works. Greenhouse gas molecules stop infrared heat from leaving the atmosphere. The sun warms the earth. The sun's energy is absorbed by the earth and the earth emits the heat energy in the form of infrared rays, which affects people a lot on this earth. And let's go to the next slide. How does coal affect human health? Coal impacts air pollution. They include mercury, lead, sulfur dioxide, nitrogen oxides, particulates, and various other heavy metals. Health impacts can range from asthma and breathing difficulties to brain damage, heart problems, cancer, and neurological disorders, and premature death. Physical effects on human body: premature death, as we have discussed in the above lines, cardiovascular effects, and nervous system effects. These are the major effects uh, which could affect human health due to coal emissions. And then let's move on to the next slide. Estimation of external expenditure of coal, like how the world is expanding on the coal and the distribution of electricity through burning coal. Estimates of external costs of coal in cents kilowatt per hour of electricity in 2008 as per US dollar. Type of impact: land disturbance, low, risk, and high is 0.34, and methane emissions from mines is the low value is 0.03, best is 0.08, and high is 0.34. And public health burden in Appalachia, which is a place, is 4.36, 4.36, and 4.36, which which affects a lot on people. Fatalities due to coal transport 0.09, 0.0, which is same measure. Air pollutants from combustion 3.32, where in Western High 9.31 and 9.31. Lost productivity from mercury emissions 0.01, 0.10, 0.48. Excess mental retardation from mercury emissions, which is at low 0 and best 0.02 and high 0.91. Excess cardiovascular disease from mercury emissions. Low is 0.01 and best is 0.21 and high is 0.05. Climate damage from combustion emissions of CO2 and N2O is low is 1.02, best is 3.06, and high is 10.20. This is the second highest value which is indicating in the table. Climate damage from combustion emissions of black carbon, low is 0, best is 0, and high is 0.01. Subsidies 0.16, 0.16, and 0.27. Abandoned mine lands 0.44, 0.44, and 0.44 in all three sectors, which totals everything of low value 9.36 and the best value is 17.84 and the highest is 26.89. This is how estimation of external expenditure of coal happens throughout the world, not only in India, not only in US, not only in China, not only the world power country, but Throughout the world, this is how the estimation of external expenditure of coal. This is how which affects on human life and human health. So that's all for the cleaning of coal PPT. Thank you all.